Hey, so in this demo, we're going to look at how we can leverage Camel Quarkus to integrate basically a change on a website to a Telegram channel. So basically, if a particular value on a website is changed, we want to be notified in a Telegram channel of that change. And I'll tell you exactly what the use case is coming up. So technologies we're going to be using: Camel Quarkus, of course. Camel, with its enterprise integration patterns, is a perfect use case here. Quarkus for really fast scaling, fast deployments on Openshift. We're going to be using secrets and config straight in Quarkus. You know, Quarkus can integrate with Openshift, with Kubernetes. We're going to configure those secrets and config maps. We're even going to be able to change the config map if our value is changed, so that we don't continue to repeat ourselves. And so lots of really cool technologies. Stick around. I'll show you exactly how it all works right now. All right, so first things first, what are we actually going to be scraping? Well, it's this website that Brussels, Brussels, Belgium government has put in place for COVID vaccination scheduling. And so essentially they do it by age groups. And so they post on this website which age group is eligible to get their to schedule their vaccination. So as you can see here, all the people, well, this is in French, of course, because it's Brussels. Could be in Dutch as well, of course. But anyway, so there right now, for example, all the persons who were born in 1985 or before are eligible, can go and sign up to get COVID vaccination. And then we're going to see that if that year changes, that we want to send a Telegram notification so that people who are born in 1986, for example, can be like, oh, cool, I can sign up now. And so that's kind of the idea of this application. And if you want to get your hands dirty, you want to play around with it, go to GitHub, kdubois/datascraper, and you'll find the source code and instructions on how to set up that Telegram bot as well. It tells you, kind of the bean and the service that is being used, the camel route, how to store the Telegram token in chat ID to be able to use it, how to run Quarkus in dev mode to test it out, and then also how to build and deploy the application. So really, it's quite simple. Maven clean package, P native, so profile native. So we're going to actually run it as a native, build it as a native binary, deploy it to OpenShift with Quarkus Kubernetes deploy equals true. And then we've also configured it to run as a Knative service. So it's going to deploy, it's going to run really fast. And then after a minute or so, it's going to scale down to 0 and use virtually no resources until we call it again. And so in this case, I've configured it to run only once, and then an external source, a ping source, will call it every 10 minutes to basically scrape it again, see if there's a change, and then if so, send a notification. If not, do nothing. And then also update the config map in case it has changed, so we don't have to constantly get messages from Telegram once it has changed, right? So we want to be able to update the config map to keep track of that. And so to be able to integrate with Telegram, we'll need to sign up for a bot in Telegram. So I've done that through the bot father, and then I've signed it up and had it join this BrewVax notifier chat group, and that's where the notification will be posted once we get it all up and running. All right, now jumping into the code. So here we can see the camel route, and so you can see that it just runs once. It calls the data scraper bean. That's going to actually go out to that BrewVax website, scrape the data, look for that year, and then we're going to log what the current year is, so the one that we get from the scraping. Then we compare that with what's in the config map, and then if it's changed, then we're going to set our body to the current vaccination registration year has changed and is now current year. We're going to log it. If the chat ID ID is not 0. So, as long as we have a chat ID set, we're going to assume that everything for Telegram is configured, and we're going to send our message to Telegram. And that's basically all there is to it, right, in terms of the route. So pretty easy to build. The data scraper class itself, we can take a look at that. So again, fairly straightforward. Quarkus application uses some dependency injection. We use our config properties that we've configured either in the application properties and or overridden by the config map and the secrets. We saw that in the Bruvax bot part as well, right? So the token and the chat ID that are actually coming straight from Openshift, from Kubernetes secrets, and is injected straight into the code thanks to Quarkus. So if you look at the application properties, we've set some defaults here, but really the magic is right here. So we have Kubernetes config enabled equals true, and then we're defining which config map Quarkus should go and retrieve and make available to the application. And then same thing with the secrets for Telegram. In the data scraper namespace, we're going to enable Quarkus to use secrets, and then we're going to look for a secret named Telegram. And that's what basically all we need to do to wire it all up in Quarkus. Quarkus is going to configure it, how to use it, but it's also going to configure the RBAC settings so that the service account that is running the application actually has access to read the secrets, which isn't by default enabled. So Quarkus handles that part too, which is pretty cool. Some other settings here that are interesting for our deployment is, for example, the base image that we're going to use to build our application container image. The registry, we're going to use the internal registry of Openshift. We're going to build the container image using the Docker build strategy. We're going to use the container runtime Podman on my machine, and we're going to deploy it as a Knative application. And yeah, so that's about it. So if you remember on the Bruvax website, the string we were looking for was this particular one, right? Like, toutes les personnes nées en, and then the year would come right after that. And so we're saying right after that, we're looking for the next 4 characters to extract the year. And this is, of course, the website we're looking at. So, all in all, pretty straightforward to configure. And maybe just for completeness, I'll show you the config map that we're adding. It's a really simple one with data Bruvax year 1980. In terms of RBAC, what I did have to configure myself in this case was the capability to patch a config map so that I can update a config map straight from Quarkus, straight from Java. The secrets, in this case, I guess you don't get to see the actual secrets. This is just kind of a template that you can use and then rename that as secrets to be able to use it. And this service is actually not used, so that's going to be generated automatically by Quarkus. So once the application runs, or when the Maven command runs, it's going to create the native runtime, going to create the build and everything. It's also going to create in our target a Kubernetes folder, and as you can see here, there's a Knative YAML file. And basically that's what it's going to generate, and that's what it's going to push to OpenShift to deploy the application and create the container and everything. Now the cool thing is, so in development mode, when you're developing, you're pushing it to your developer OpenShift now, to test it out. But ultimately, you'll probably want to use something a little more robust to push it to production. So you can actually use this as your base for your GitOps operations or whatever automation you want to use to push the application to your production server. So you have kind of the starter template that you can configure if you want to deploy the application to production, which is very handy, right? That you don't have to come up with all this yourself. So this basically means that Kubernetes kind of out of the box with Quarkus. So to finish it all up, so if we want to do, if we want to push it to OpenShift, well, let's first see OC project, make sure that I'm on the right project. Yes, I'm on the data scraper project. Maybe we can even delete it. And then completely start from scratch to show you that it's actually all, you know, working the way that it's supposed to, and it's not just, you know, some blah blah. All right, so now we're gonna create the project, new project, data scraper. All right, and then we're gonna just apply those few cube files that we talked about. So OC apply or a kubectl apply like you want. Cube files, configmap, RBAC, secrets, in the namespace, data scraper, but that should already be set anyway, so apply those. Okay, now I've also created a ping source. Now you can do this through the UI pretty quickly, but you know, I've extracted it, and so I can just apply it from here. OC apply cube files, ping source, and that's going to make it that the application gets called every 10 minutes to spin up a container, to spin up a pod. Go to the website, look if the date has changed, and then you know, all the good stuff that we talked about earlier. So with that, we should be all set to deploy our application. So let's go ahead and do that. So Maven clean package, profile native to build it as a native, binary, Quarkus Kubernetes deploy equals true to deploy it, to build it and deploy it to OpenShift. And then here we can see how it's pulling the base image, going to create a container image with the built binary, combining them both, and then pushing it to OpenShift in just an instant. Boom, done, build success. And so now if we go look at OpenShift, we should see everything deploying. All right, so in here in OpenShift, we can see that a revision is being created. We can look and see that pod is running and look at the logs. And so current year is 1985, previous year was 1980, and so a message was sent to Telegram. And then here we can see it in Telegram. The current year has changed and is now 1985. Yay, so it worked. And then we can see that the pod itself will soon start to scale down to 0, and then we'll wait for our ping source here to start deploying, or to kick off a next build. So here we can see pod is terminating, and so basically no resources will be used after that. All right, if you like this demo, please definitely let me know in the comments. If you want to learn more about Quarkus and Camel Quarkus, you know, Quarkus.io is a good starting point. In terms of support, Red Hat does the Red Hat build of Quarkus, which provides you with you know, obviously support stable build of Quarkus that's been secured, tested, and all that good stuff by the Red Hat team. So that's I would definitely recommend that as the way to run it in production. Yeah, like I said, thanks for joining this demo, and see you in the next one. Thanks.